So we have the topic moment or the turning effect. So when force is applied on the object and it causes a rotation, what we call that as a moment. And a moment, it's a vector quantity. It can be a clockwise or anti-clockwise moment. But how we can work out the direction of the turning effect? It's for example, it depends on the object itself. You can have, so you can use the object, like example, you can use your pen as an object, but this is used for the objects which are having a very small size. So we want to work out the turning effect of this object. So how it can be done? Like I have the pivot here, the point of the rotation, and the weight is acting downward. And I want to work out which direction this will cause the turning effect or the moment. So what I will do, I will hold my pen from the pivot. So I will consider, because the left-hand side is a pivot, so I'll hold my pen as a pivot. And now weight is acting downward, so I'll apply by using my fingertips, I will apply a force in the direction. So which direction you find it is rotating with reference to you. So when you work out the direction of the rotation, which direction it is rotating in a direction of a clock. So means this will cause a clockwise turning effect. But same thing, if I change the position of the pivot, now the same question, the weight is acting downward, but we change the position of the pivot. The pivot is towards the right-hand side. So I will hold this time from the right-hand side and I'll apply a force downward. So now which direction it is rotating? It is rotating opposite to the direction of the clock. So means this causes an anti-clockwise. So that's how you work out the direction of a rotation for the planks or the rods. That's how it can be worked out. But what you have a box and you want to work out the direction of the rotation of a box. So in that case, you will use a paper. So if you have an object which you will consider a box is there and you don't want to understand which direction it will have a rotation, clockwise or anti-clockwise. So this is a point of rotation or a pivot and its weight is acting downward. So I will use my paper. I will hold it from the direction in which, like there's a pivot, and I will apply a force in the direction of the weight. So where the weight is acting downward. So when I apply a force, what I observe, like this is a paper, I hold it from the pivot and I apply a downward force. So when I apply a downward force, which direction it tend to rotate, clockwise or anti-clockwise? So it tend to rotate clockwise. If there's another horizontal force is there and I want to work out which direction it rotates, so I will hold it from the pivot and I apply a horizontal force on this. So as a result, what will happen? It will rotate anti-clockwise. So that's how you work out the direction of the rotations. Is it clear? So for the rods or the planks, you use your pen as an object and hold it from the pivot and apply a force in the direction. But what if you have a box? In that case, you will use a paper to identify, hold it from the point of the rotation, the pivot, and apply a force so you can identify the direction of rotation. So whenever we apply a force and rotate an object, we call that as a turning effect or moment. And related to the turning effect, we have a condition that is equilibrium. The term equilibrium means that the object, if an object is at rest or it is having a constant speed, we call that object is in equilibrium. What are the conditions for this object? For object to be in equilibrium, there should be no resultant turning effect or a moment, and there should be no resultant force. Both conditions must fulfill to say that object is in equilibrium. If one of the condition does not fulfill, we will not say object is in equilibrium. Example, So here is an object and we have a pivot at the center. The point of rotation is there at the center. The forces which are acting, a 10 Newton force is there downward and a 10 Newton force is also downward. This force is at a distance of 2 meters. This force is also at a distance of 2 meters. And the pivot apply, because there's always a force from the pivot example, apply a force of 20 Newton. Now we want to check that whether this object is in equilibrium. So first, a force of 20 Newton towards the right-hand side. So there's a force of a 20 Newton, which is towards the right-hand side. So which direction this causes a turning effect? A force of 20 Newtons, 10 Newtons toward the right-hand side. Which direction this causes a turning effect? So I will hold this pen from the pivot, a point of rotation, and I will apply a downward force. So when I apply a downward force, what I will observe? I'll observe that this is causing a clockwise turning effect. And what about the other one? I'll hold from the pivot. I'll hold it from the pivot and I will apply a downward force. So when I apply a downward force, so what it causes? It will cause an anti-clockwise turning effect. So this is causing an anti-clockwise, the other is causing a clockwise turning effect. And how much is this? 10 multiplied by 2, 20 Newton meter. How much is this? 10 multiplied by 2, 20 Newton meter. So the total clockwise and the total anti-clockwise turning effects are equal or balanced. So the first condition of the equilibrium is fulfilled, that there is no resultant turning effect or the moment. The second is there should be no resultant force. So if we want to check no resultant force, we check the total. What is the total downward force? 10 Newton and 10 Newton is a total downward force. So total 20 Newton is down. And the force from the pivot is also 20 Newton. So what is the resultant force? The resultant force is also 0. So means the two conditions of equilibrium are fulfilled here. So I can say that this object is in equilibrium or balanced. Is it clear? Now, if we have another example, and the object is placed on the pivot, the fulcrum, and there is a force of 10 Newtons at a distance of 2 meters, another force of 10 Newton at a distance of 2 meters. So, and there's a, so as a result, when we work out, this will cause a turning effect. This is also causing a turning effect. So it will be 10 multiplied by 2, which will be equals to 20 Newton meter, opposite to the direction of the clock. And here this will be 10 multiplied by 2, 20 Newton meter, same as the direction of the clock. So first condition is fulfilled, that there is no resultant moment because the 20 Newton clockwise balances with the 20 Newton anti-clockwise. But what about the resultant force? When we work out the resultant force, the 10 Newton, a resultant force of a 10 Newton and 10 Newton, so total resultant force of 20 Newton is there. In weight example, if we neglect the weight, if there's no weight for this or a negligible weight, so there's a resultant force of a 20 Newton. So as a result, the second condition is not fulfilled. So if the second condition is not fulfilled, we will not say this object is in equilibrium, even though the resultant turning effects are balancing, but the resultant force is not balanced. So whenever object is in equilibrium, you have to check both conditions, the resultant turning effect as well as the resultant moment as well. What about the force acting up the pivot? But what will happen because of the two forces? Yeah, the force acting by the pivot here. So all the forces are acting upward. There is no downward force to balance that. Or the weight might be there. If you consider the weight of object is there, but that is negligible compared to the total upward force. So again, what will happen? It won't be in equilibrium. So the turning effect of the force is refers to a moment. And whenever object is in equilibrium, it has no turning effect. It does not have no resultant force. There's also another thing which is known as the moment of couple. What is the meaning of the term moment of the couple? When two forces are acting in opposite directions, but produce. So when two forces are acting in opposite direction and produce the moment in same direction, we call that as a moment of the couple. The best example, the steering wheel of the car. For example, if you want to rotate the steering clockwise or anti-clockwise, so what we tend to do, like example, if this is representing the steering, so this is representing, example, this is representing a steering. So if I want to rotate, I want to turn the wheel towards the right-hand side or move the car towards the right-hand side. So how we apply a force? Our right hand is on this side and the left hand here. So when we want to rotate the wheel, what we do? We, from our right hand, we apply a downward force. From our left hand, we apply an upward force. And this is a point of rotation or a pivot. So as a result, one of the forces downward, another force is upward, and we produce a turning effect in the same direction. As you can see here, what is the turning effect of this one? Force into the distance. So the turning effect is clockwise. What is the turning effect of the upward force? The force is upward and the distance is d. So what is the turning effect? Clockwise. So when two forces are acting in opposite directions and they're producing the turning effect in the same direction, what we call that as a moment of a couple. And if you want to calculate the moment of the couple, how it can be done? Because the two moments are in same direction. The two moments are in same direction. So the force multiplied by distance. Is it lagging my audio or it's fine for everyone? Now it's fine. Okay. So example, what is the turning effect of this? So F into D. What is the turning effect of this if we apply a same force? So F into D. So if we, because they're acting in the same direction, so what is the turning effect? The total net turning effect. So if it will be F into D plus F into D. So F we take common. So it will be D plus D. Means like D plus D or 2D we can say. Or if I say this distance is R, like if I say the total distance, so it will be F multiplied by 2D, you can also say. That will be the net turning effect. So if we know the force and we know the distance between the forces, we can work out the moment of the couple or the turning effect of the couple. Is it clear, the concept of the moment of couple? Yeah, in this example, the forces are same. If two forces are in this example, I took the forces as same. If two same forces acting in opposite direction and produce the turning effect in the same direction, we call that as moment of couple. So as we were discussing the moment or the turning effect of the force, here are some questions related to the moment or the turning effect. So as you can see here, a uniform plank of a length A and B, of plank AB of a length 5 meters, weight 200 Newton is placed across the stream as shown. A man of weight 880 Newtons stand at a distance of X. The ground exert a vertical force of Fa on the plank at the end A and the vertical force Fb on a plank at the end B. As the man moves along the plank is always in equilibrium. When we use the term equilibrium, means it is the balance, like there's no resultant force and there's no resulting turning effect. Explain why the sum of forces Fa and Fb is constant no matter where the man stands on the plank. Like the man is standing at a distance X, but if we move forward, the total will not change. So what is the reason why the total does not change even the man move anywhere on the plank? So the main reason, yeah, that's right. Because what will happen, there is no result as it is in equilibrium. How we write the structure of this answer? That's good. One of the student mentioned that the weight does not change if we move horizontally. So that's a good answer. But how to structure this answer? The first thing we'll mention, it is in equilibrium. So it is in equilibrium. So as it is in equilibrium, there is no resultant force. So it means the Fa plus Fb will always be equals to weight of the man and plank. And as the man moves, the weight does not change. The weight of a man does not change. The weight of the plank does not change. That's why the Fa plus Fb, the sum of Fa and Fb will always be constant. So that's how you mention that's how you structure your answer. It is in equilibrium, so there's no resultant force. So means the upward force should be equal to downward force. The downward forces are the weights, and the weight does not change if we move horizontally. The weight of the plank and the weight of the man does not change. That's why it will remain in equilibrium. The man stand at a distance x, which is 0.5 meters. Use the principle of a moment. Calculate the magnitude. What if there is a different weight on the plank? Yes, in that case, for example, if we add another weight, in that case, the sum of Fa and Fb will change. Because right now, Fa and Fb is acting upward and the weight of the man and the weight of the plank is acting downward, they're balancing. But if we add another load, so that load, the sum of Fa and Fb will also change. Now we need the magnitude of Fb. Whenever you see 2 points of the contact, whenever in a question you have 2 points of contact, so you have to take one as a pivot. It's up to you. Any one of them you can take as a pivot. So example, I'm taking A as my pivot. So if I take A as a point of rotation or pivot, so I'll take all the moments about A. So this will cause a clockwise, this will also cause a clockwise, and this will try to cause an anti-clockwise. And how will identify that which is causing a clockwise or anti-clockwise? So I'll hold my pen. It's a plank. So whenever there's a case of a plank, I'll hold my pen, and the man weight is downward, so clockwise. The plank weight is downward clockwise, and the normal contact force at B is it anti-clockwise. So that's how we worked out the positions, the turning effects, the direction. So what is this one? It will be 800 into X. What is this one? 200 into 2.5. Why 2.5? Because the total length is 5, so the half will be 2.5, and they mention it's a uniform plank. There is a force about A. There is a force about A, but this does not cause any turning effect because it is acting on the pivot. So the turning effect of this force is 0. There is a force, but it does not have any turning effect. And what about the turning effect of this one? So FB into the total length 5. So we will consider A as a pivot. The clockwise and anti-clockwise turning effects are same. 800 into X, and the value of the X is given in the question. It is 0.5. I can substitute 0.5 there. So 800 into 0.5 plus 200 into 2.5 FB into 5 multiplied, other side will be divided. That will give us the value for FB, which is 188 newtons. Is it clear how we worked out FB? So whenever in a question you see 2 points of contact or 2 points of rotation, any one of them you can consider as a pivot. So this is 188 and we don't know FA. So how we can work out FA? We can consider the total upward force. How we know the distance of 880? It is given in the question that the value of the X is 0.5. 0.5. It's given in the question. How we can work out FA? So FA is acting upward, 188 is acting upward, 880 is acting downward, and 200 is also acting downward. So FA is equals to 880 plus 200 minus 188. That will give us the value for FA. Which is 892. The next is the variation is there. The variation is there with the distance X for FA. On the axis, draw a variation for FB. Like how FB changes as X is changing. Remember one thing, that what should be the sum of FA plus FB? The sum of FA plus FB should be equals to 880 plus 200. 880 plus 200. The sum should be 1080. The sum should be 1080 Newton. Sum will not change. If FA, so example, if this, any value you can work out. Example, here 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 boxes equals to 500. So each is representing 50. So this will be 900 and because it is between 1000 and 950. So this will be 975. So if this is 975, what will the value for FB? What should be the value for FB? So 1080 minus 975. That is one way of doing. Or yeah, 105 is there. The value will be 105. So it means, because if I need FB will be 1080 minus 975. So this will be equals to 105. So when the X is 0, because if 975 here, so this will be 105. So this is 50, and this 100, so 105 somewhat here. So that is the starting point for FB. If the value of FA is like 100, what should be the value for FB? If the value is 100 for FA, what should be the value for FB? So we subtract, so it will be 980. So 980 somewhat it will be here, like this point. So, and the linear change is there. The values change linearly. If the value of FA increase, the value for FB will decrease. And if a value of FA decrease, the value of FB will increase. But the total sum will remain same. Is it clear, this one? How we sketch the graph, the position? Anyone having a doubt or a question related to this part?